Hi, in this video we're going to take a look at a couple of affordable FPGA starter kits to get you into FPGAs. So what I've got here is a couple of basic entry-level FPGA kits. Three on the top here are sub $100 boards that allow you to get up and running. This is the Papilio One Xilinx based FPGA board, similar sort of style to an Arduino thing. You can connect wings on here and stuff like that. You can even get an Arduino compatible soft-core processor to program inside this thing, and this thing's under $50, and it's got a decent Xilinx FPGA on there. Then we've got this TUR ASIC DE0 Nano board, and this one is an Altera based board, and it's a nice little compact thing like that. This one is $89 US. I think it's as little as $49 for US students, so that one's quite reasonably priced. Then we've got the Digilent Basys 2. It's an Xilinx compatible, like the Papilio One. It's got a Spartan 3E, same as what's on the Papilio there, and yeah, it's a neat little unit. This one only costs around $79 or $59 student price, so not bad at all. It has a VGA output, as we'll take a look at. And then we have a higher end one, which is the MicroZed board, and it's Xilinx partnered with Avnet, and yes, this is the exclusive Dave Jones edition. Beauty. If you're going to get this, get the Dave Jones edition one, trust me. And this is basically a Xilinx, but it's not one of their Spartan ones, one of their low-end Spartans. It's one of their really modern high-end Zinc ones, and this is an incredibly powerful board. $199 for this board, but it can run embedded Linux, and I think it comes actually pre-programmed with embedded Linux, and it's got Ethernet and the whole works. So quite a really powerful beast, and we'll take a look at that in more detail as well. So take a look at the Papilio board here, just an example of what's required bare bones to get this thing up and running. Once again, this is a fairly fine pitch quad flat pack chip, so it's not something you can just immediately mount on a breadboard. For example, we need an external oscillator to make the damn thing work. Then we need our platform flash memory connected to it so that it can store our programs when we remove our power. We've got multiple voltage regulators up here, 1.2 volts, 2.5 volts, 3.3 volts, therefore all the various core voltages required by this particular Xilinx Spartan 3 FPGA. And then we've got the USB interface here. I mean, you don't necessarily need this. You could have just had a JTAG header on there and just plugged it straight in and then used an external JTAG programmer for that. But all of these boards have USB built in, so you can just connect them straight up to your PC, and that's what you want. And if you do want to program these things yourself, which, yeah, it's a great thing to do, I highly recommend it. Just watch out for all the traps for young players. You can get the external programmers, in this case JTAG programmers. Xilinx do this one, the platform USB cable. This one's fairly cheap on eBay, not as cheap as the Altera ones. This is not a genuine one. This is actually a rip-off one, and so is this Altera USB blaster one. You can get these for, like, I think this one is like something crazy like $8 delivered or something ridiculous like that. So Altera does seem to have a lower entry point price as far as the JTAG programmer tool goes. That is supported by the official manufacturer software. Now, the two major players in the market, well, in fact, all the FPGA players in the market, but the two main ones are Xilinx and Altera. They all offer free tools, and as you can see on this Basys 2, it's advertised that you can use the free CAD tools from Xilinx, in this case the ISE Webpack. It's a massive download, of course, but it is completely free, and Xilinx have Altera have their version as well for free. But the free versions of the tools don't necessarily support the higher end FPGAs. So that's why if you're going to get one of these boards, you have to ensure that it is suitable for use of whatever FPGA you choose. You have to ensure that is compatible with the free tools. Otherwise, you'll be paying a fortune for the FPGA tools. Now this Papilio One is an open source hardware type platform, but it is very basic. I don't think it's going to be as sort of, hand holding as some more of the kits from more of the mainstream providers. Brief look at the DE0 Nano here. I rather like this. Really compact little form factor. Nice 0.1 inch headers on here. And, well, let's actually, there's some stuff on the bottom, memory and bypass and things like that. And also another header on the bottom to plug it into stuff. Mounted on standoffs. Neat little self-contained unit. And as I said, it's got a Altera Cyclone 4 FPGA. It's got a USB interface. It's got an E2 Prom. It's got, what have we got? 4 dip switches. It's got an accelerometer built on. Fantastic. If you're in your accelerometer stuff, it's got an ADC in there. What else have we got? We've got 2 push buttons, 40-pin GPIO headers, 32 meg of SD RAM, fairly chunky amount of SD RAM in there, and it's got a serial PROM to program the, to hold the configuration program, and 8 LEDs, so not a bad little board. I don't mind that at all. And the other really good thing about the DE0 Nano, it comes with the software, so you don't have to download it, and most importantly, the Altera Complete Design Suite, the free package, because this is absolutely huge. As you can see, it's on a DVD. It can be multi-gigabytes to download the various packages from the manufacturers. This one supplies it for you. The others don't. And the Basys 2 board, it's much larger than the DE0 Nano. There's a comparison there. 0.1 inch female headers along here, so not as many I/O as you get on the DE0 Nano, but you do get more nice, big, chunky switches and buttons. We've got a 4-way LED display here. You can have it as a clock. What I really like is that it's got a VGA output, and that's really quite nice, because one of the best examples for an FPGA is being able to interface to a VGA monitor, because you can pick up VGA monitors from the garbage room for nothing, right? People throw these out, but they make great interfaces for FPGA projects. So this one allows you to experiment off the bat with that. So that's really quite good, at the expense of some I/O along here. But yeah, once again, it's got the platform flash memory, multiple clock sources once again, Xilinx Spartan 3E this time instead of the Altera part, and it's got a PS2 port on it as well. And you can get modules that actually plug into this. This was, I'm not sure of what type or how much they are, but anyway, you can plug those suckers in. But I really like this one because it's got a VGA output you can experiment with, and presumably some example programs to drive the VGA. And this much more upmarket MicroZed board is a $199 one. Unfortunately, it doesn't really come with any I/O, like usable I/O. Of course, it's designed to have embedded Linux. It uses the high-end Zinc FPGA, really neat. It's got a built-in ARM 9 processor, really powerful thing. Runs embedded Linux. I think it's already pre-programmed with it out of the box. We have to power it up and have a look. Ethernet interface, of course, but all of the I/O here is on the bottom. It's got an micro SD card on the bottom. All the I/O here is designed to plug into a rather expensive I/O board, which I don't have, wasn't provided with this thing, which is a bit of a bummer. It's a really big board, which I'll post a photo of right now, that just breaks out all of the I/O into handy usable stuff. So if you're going to get one of these, I'd recommend you spring the extra and get that I/O board. I stand corrected. This sucker contains 2, not 1, but 2 1 gig 1 gigahertz, folks, ARM Cortex A9 hard processor cores in there, as well, of course, as all the FPGA fabric as well. It's got 2 1 meg sample AD converters as well. So really powerful board, that one. So if you're looking to run something inside a traditional, inside a traditional processor, these hardcore ones are better than, the soft cores you can program into almost any FPGA, as long as it's got enough gates inside, enough room in there. You can program various different types of soft core processors into these things, but something like this dedicated ARM 9 1 gigahertz processor in there cannot be beat. Really really, it just absolutely kills any soft-core processor that you can program into any other FPGA fabric. And also, you don't want to piss away your FPGA fabric inside these things with a soft-core processor. Like, you might put a soft-core processor in here, but it might use, I don't know, just as a guess, you know, it might use 10 or 20% of your FPGA space, depending on what type of processor it is. Oh, don't want to waste it. And they're usually not going to be very quick. Like the FPGA itself, for example, might be very, very quick, but when you compile in, not the correct term, but we'll use that today, an FPGA core, soft core into this thing, it can't run, you know, at nearly that speed. You can get them to run at tens of megahertz, 50 megahertz maybe. So this certainly won't be a complete tutorial in how to, you know, set up and run these things. I basically won't show you anything. I'm just going to install it and get them running. And that's the whole idea. How easy is it to get these things running? I'll just tell you in the end. I won't show you all the horrible steps to it. So we'll start out with the DE0 Nano. And that, of course, has the Altera Cyclone part on it. So we're going to install the, thankfully, the software comes on that DVD. We didn't have to download it, however big it is, however many gigabytes. We're just going to install that. So here we go, install free package, and well, see what pops out the other end. And when you install it, you have the option to install Quartus II. You have to install that. It's the free web edition. It is the actual suite of tools for all the FPGA stuff. So there's no getting around that, but you can also install the model sim as well, and that's just simulation stuff. And most beginners probably don't need model sim. So if you want to save the 2.7 gig, you certainly can. And that only took 23 minutes. That wasn't too bad, I guess. Can be a lot worse than that, trust me. And, well, no, I don't wish you to talk back, enable sending talkback. No, go away. Anyway, it's finished and it installed, as you can see, well, it installed all the different families down here, not just the Cyclone 4, I think, which we need. It installed, you know, Stratix, real high-end stuff, Aria, and all those. What the FPGA is this garbage? Altera software install, it started thrashing the CD drive and locked up. This was after it said it installed and everything was hunky-dory, and this just goes on and on and on forever. You've got to be shitting me. Ah. And on the other CD that comes with it, there's no install file or anything like that. There's just some subdirectories with all the stuff. There's various demonstration programs. Oh, look, my first FPGA. That sounds neat. There's all the files for the Altera Quartus stuff, the ADC stuff, and yeah, there's the accelerometer by the looks of it. So that one looks quite neat. And then we've got the data sheets with the all of the various parts. That's pretty handy. And we've got the schematic. Fantastic. And we can load that up. And bingo, there it is. And we're going to have a look at how they've implemented this thing. There we go. Not sure what package they've used to use that. It's not Altium. But yeah, once again, they've done all the separate pages. This is very common for these FPGA vendors. Sometimes it's good, sometimes it's not so great. That's how they've implemented the configuration prom and the JTAG interface, and everything's just spread over a couple of pages here. So that is a little bit annoying, but there you go. They give you all the complete schematics which you will need to interface this thing. And you notice here's all the power supplies, 3.3 volts, 2.5 volts, 1.2 volts for the various cores on the FPGAs, because these FPGAs can be a real pain in the ass. Now, according to the Quick Start guide, we can just run one of the demonstration programs here, a batch file in here, after installing our Quartus II software, which we've done, and Bob's your uncle should download, and everything's right, because these FPGA tools are actually command line tools. You don't have to use the GUIs. And in fact, you know, that's how a lot of third-party tools integrate with these FPGA tools, is they're all command line driven. So let's go in there and try it. G sensor, here it is, demo batch. And because there's no batch file in there, so we should have to just run test bat, I guess. Let's see if it works. Does it work? Demo. No. Wah. There was some red thing there. I saw it. Oh, fail. And that error message was that it hadn't detected my USB blaster, because this board actually has that USB blaster functionality and compatibility built in to the board, as I showed before. You could buy for like $8 that external programmer. It's built in, but look, it just didn't install properly. It's supposed to do that when you install the Altera Quartus software. You gotta be kidding me. Alright, I manually installed the drivers there in the usual location in the Quartus software under /drivers, Quartus /drivers /USB blaster, and did the usual Windows thing. So one more time for the dummies. Here we go, test bat. Woohoo! Look, it's doing it. It's doing it. It's doing the business. Oh, it's doing something. My LEDs are still flashing. By the way, that LED... Knight Rider type thing, came pre-installed with the board, which is really quite nice. Oh, there we go. Looks like it's done. It worked. A treat. Beautiful. Get over that driver issue. Not a problem. Thumbs up. And yeah, check it out. We are in a command line interface. I mean, look, I can go CLS and it actually clears the screen. Hello. Command not found. Now, this certainly won't be a tutorial on how to use Altera Quartus II, that's for sure. I just wanted to show that we can actually load our project into that. And all I did was double-click on the project file within that demo subdirectory, that accelerometer sensor we just ran, and bingo, here it is, loaded into Quartus II, and there's our source code. Fantastic. And if we wanted to, of course, we can just modify our demo program. Then we can go over here and actually compile the thing. We can analyze, synthesize, fit, and then program the device down there. So we can just double click on analysis. Do you want to run the task again? Yep, here we go. It's going to go through analysis and synthesis. And yeah, it was successful. There's 6 warnings. Not a problem. So it all just works. Total logic elements. There we go. Only used 189 logic elements. Total dedicated logic registers. Total registers 112. Not much at all. And then we can do the same thing for the place and route. Here we go. It's almost complete there. And it should... successful. 4 warning error messages. Total logic elements used, look, less than 1% of what that FPGA is capable of. Total pins, all that sort of jazz. Beautiful. Total memory bits and total PLLs used. It's using 1 PLL. There's 4 phase lock loops within this FPGA. And there you go. That's a handy little summary. And there's a million different things and resources we can check and things like that. One neat one is the resource utilization by entity here. You just go into analysis and synthesis and it can give you all this sort of info. But this basically tells us how many logic elements in our FPGA are being used by each particular Verilog routine there within our program over here. So that's rather neat. Let's try a more media project. I've opened up that Nios embedded core demo program, and I've done the analysis and place and route on that, and it didn't take that long. And look, here it is, summary of that. After the place and route, I've only used 26% of our cheap ass FPGA to run that softcore. It's running external DRAM and everything else, so that's pretty good, on a low end cheap ass board like this. I like it. Now, there's a million and one neat different things we can do with all the tools built into this thing. But one I really like is the power analyzer. Now, after we run the assembler down here, then we can go up into our tools. And, there's a whole bunch of tools. There's a million and one tools. We can do logic analyzers, signal tapping. Oh, good stuff. Anyway, let's go to the PowerPlay power analyzer tool. And we can run that. I've already run that. And we can go to the report here. Hello, McFly. Come on, go into the report. There it is. It simulates the whole thing, tells us how much power that program is going to be running. And here is total thermal power dissipation, 282 milliwatts to run that Nios softcore processor there. So, that's pretty neat. And here's a summary of the results. 315 milliwatts total thermal power dissipation for that Nios core there. But we can go in and we can get all sorts of things. Total power dissipation by block types. We can get power dissipation by hierarchy here. Come on, this is slow as a wet week. Oh man, I'm only running a 2 GHz Core i7 here. Not sure what's going on. Maybe it's my screen capture in the background. But all these breakdowns of all the power dissipation. Fantastic stuff. And you can even get an estimate of what current is going to be drawn here from each of the individual power rails. Like the I/O, that was based on I think it was a 12.5% toggle rate or something like that. So it's just an estimation, but VCCA, VCCD, the internal power dissipation, the static current, fantastic. And of course, one thing you're definitely going to want to, well, you're forced into when you're doing FPGAs, one of the big things is, of course, assigning pins, because the pins can do many different functions. So Altera Quartus II has the pin planner here, and this one's obviously already loaded up for this particular project and this particular device here, the EP4C blah blah blah, and you can see for the BGA part all of these ridiculous symbols for the pin outs, but you can go in there and you can form groups, the DRAM, where the DRAM's connected to, and the GPIOs and the keys and the LEDs and the switches, all for, and you can create your own new groups and things like that, which then you can assign into your Verilog VHDL program to to access your I/O and things like that. So here's all our pins, all of our individual pins, and we can set the I/O standard here. We can change all that, and we can do all sorts of weird and wonderful and wacky stuff with our pin I/O. But that's, man, there's just I/O configuration in FPGAs as a 2-hour tutorial in its own right. And there's countless other stuff as well in this, in both the Altera and the Xilinx tools, and the tools from other lesser manufacturers as well. And yeah, I could do a million videos on these and still not cover them. As you can see, these are very, very complex tools, these FPGAs. And, pretty much if you're doing it at this sort of level, using these vendor tools, as they're called, then, you have to learn how to do these things. But by loading in these example projects and getting everything up and running, then it takes, and then working backwards from that takes all, at least the the hello world grief out of it, because FPGAs are incredibly difficult and complex just to get, the blinky LED going, really. But I haven't touched on one of the awesome things that comes with this DE0 Nano. If you want to create a new project from scratch, how do you do it? Well, with the disk here comes some tools, and they've got a control panel that allows you to control stuff, but there's system builder stuff. Let's give this a go. Here it is. Look at this. Terasic? Don't know how to pronounce their bloody name. It's a bit hard, but here's the DE0 Nano FPGA board, and you can EEVblog. Let's call our project here, and what do you want to use? I want to use a clock, I want to use a couple of buttons, I want to use SRAM, I want to use everything. And, oh look, 5 megapixel camera. Looks like they got some modules that you can whack on to the header. That's pretty neat. 4.3 inch LCD and touch, multi-touch LCDs. Presumably you can just buy those, plug them in. Anyway, the whole idea is this will generate a code template for you that you can work from and take all that really annoying pin configuration stuff and things like that out of the equation. So here we go. Let's try it. I haven't tried it yet, but let's generate GPIO header. There we go. Well, we've got none. Let's just go GPIO default, shall we? And let's just go generate, and it will generate. Here we go. I'll save it, and then we'll try and do something. And here it is, code generated, EEVblog, and bingo. There's our code. Let's check it out. We can load that. Just load up the Quartus project file here. And we're in like Flynn. And here is our project, or with our template already set up. Here's our DRAM configuration, the LEDs, key switches. Everything is set up, ready to go. And we can just add our own code on top of that. Beautiful. And then we've got this bit of wanky control panel software that comes with it, but it just allows you to have a basic play. It just talks to the board, and then just allows you to, switch the LEDs off and on, and, touch the switches and things like that, and, write stuff to the memory and play with the accelerometer. There it is. We can muck around, and ADC, bugger off avast, go away. And then you know, and then we can just, you know, play around with it. But really, you know, that's not a huge value add. That's just more of a toy. But that system builder stuff, that is a real Bobby Dazzler. Let me tell you, that is essential for beginners to build, to generate those code templates to get you up and running, because nothing is worse than your FPGA that just, you know, that just does nothing. As a beginner, you just, you know, try to get and configure all your pins and just get all the assignments and everything working just so the damn thing compiles, and that can be a real hurdle. Whereas that code generator, huge step